Also wanted to do quick introductions because we do have a bunch of folks who are either from out of town or don't normally join us. So this is a little bit of that. We've been around for 11 years. Actually, I think about 11 and a half years. So my name is Chad Green. I'm Director of Software Development at a company called ScholarX, where we do medical training software. And Ed Charbonneau is a developer advocate at Progress, or everyone better knows as TaleLearCode. So the two of us run this group. And we try to every month have great speakers like Sean come in and talk about topics that are of interest to .NET developers. I want to still thank our sponsors. So normally I'm saying Modus providing us with space. We're all at our homes, so Modus is not providing space, but still they normally do that. And tech systems normally would be providing the food, but they're not doing that. But then we also have Green Events and Technology, which is just my little company that I run all these events under. So technically it's paying for everything, like this Zoom account and such. All right, so some upcoming meetups. So sure enough, I was on an interview call not too long ago where the Indie Framework team was talking about basically what's coming out in 5.0. And it turned out that nothing was NDA because Indie Framework is built in open source. And so I reached out to Jeremy Lickness, who just recently became on that team, running the team, and asked him, hey, can you come to our group and speak? So sure enough, it's going to be Jeremy, who's an awesome speaker. Actually, before he was on the Microsoft.NET or Microsoft Data team, he was a cloud advocate for Microsoft, where his job was to go around and speak. So he's really a speaker. And then Arthur Vickers is one of the lead engineers on the team. That should be a really, really good talk, talking about how the framework has come up to be and what we're going to see in the future. And there are some really neat features coming out in Framework Core 5. So some upcoming events. So there's not much because of COVID, right? But there are still some things. So there's this new event, Dev Around the Sun. So this is being created by a bunch of folks that run other events that have canceled because of COVID. And so on May 12th, they're going to run an event. It's going to be a 24-hour event. And it's going to be raising money for medical causes. So you can find out more information about that at devaroundthesun.org. I would highly recommend you take a look at that. And then Codepalooza is still happening at this point. So the deal with Codepalooza is we're kind of hoping by August we can at least start meeting again. They will probably be, not probably, there will be a virtual component because I know that people won't be able to travel and people won't be comfortable in large groups yet. So there will be both in-person and virtual component to everything. How that's going to work, I'm still working that out. I'm having talks with several different groups about that. But so we will be having that. And hopefully by the end of next week, we'll be announcing speakers. We're going through evaluations right now. I'm meeting with the committee on Monday to try to go through all that. Some other events, because I do run several different things, some things to know about. So next week, we're bringing back the Louisville Microsoft Azure User Group, which kind of never really did very much, but I kind of taken over that group. And so next week we're going to meet and we're going to talk about setting up an Azure Cosmos DB, and that's actually it's a Luther. I'm drawing blank on Luther's name right now. Well, it's Luther, and he'll be talking about how to set it up. And then I'm gonna, at the end part of it, I'm going to talk about how you would build an app against that database. So that'll be next week. We still have the Louisville Tech Leaders. So if you are a tech leader, this is meant for you. And again, because it's all virtual, you don't have to be here in Louisville. But we'll have our happy hour on the 28th. So that's just a social, just like it sounds like. And then on May 12th will be our next coffee discussion. So that's get together for an hour in the morning, and just talk about issues that we're having with our teams, or that we're having with managing our teams and such. So like we met this month. The meeting was this past Tuesday, and so most of the conversation was how do you manage COVID and all the things that deal with COVID. Like for example, one of the guys on the call was runs the infrastructure at one of the local banks. And so definitely interesting situations he's dealing with, because not only does he have to deal with hardware all over the place, but a lot of people working from home and they have all this PI, right? So that was really interesting set of conversations. On May 12th, we will also have our Lowell IT happy hour. So just same thing we've been doing. Happy hour's been going on for about 6 years. We just moved it online. And then finally, I don't have a date set for May, but we'll have the remote workers meetup. Funny part about that was it was started earlier this year to actually get remote workers out of the house. But now you need to stay in your house. But still, really good. It's nice to had that last week and for the April one. And what was neat was there were several people who have been working, who don't, like myself, who work remote 100% of the time anyways. And I had a couple of folks who had just started because of COVID, right? And we're still trying to figure out how to make that all work. All right, and one last thing I want to talk about, starting sometime next week, trying to get everything finished, but I will be live coding on Twitch. This is actually something I've been talking about doing for about 6 or 7 months, and I'm finally getting around to it. So it's not just because of COVID, but it is because of that too, because I can't go out and speak at places since most everything's being canceled. So I'll be doing that. And like the first thing I'm going to be building is a online rock, paper, scissors tournament application. So sure enough, where I work, we normally have in-person meetings once a month, and we actually crown a champion every month. And it's always been rock, paper, scissors. And a couple weeks ago, when we tried to do it for our first time online, and we did it. I did find a website that did it, but it didn't do the tournament part. So so I'm gonna build that out, and with the intent of it starting out pretty easy and then building onto that. All right, so those who attend my meetings know that we always have this slide, which is actually for me to remind people that we'll go to BJ's afterwards. Well, we can't go to BJ's, but the point is we will hang out afterwards. I'll actually stop the recording, so you don't have to worry about things being recorded. And so if you say something stupid, no one will remember afterwards. No one really says anything. No one will say anything stupid, and I will probably. So at any rate, we will have that, after Sean is done with his presentation. So with that, so sure enough, Sean's a good friend of mine. Known him for a couple of years, and was actually talking about the first virtual thing we had to do, which was the MVP Summit. And I was talking about, I need to make this a virtual event. And actually, I saw this talk he's about to do at KCDC last year, and it was an awesome talk. Definitely, looking at, not really going into details of how to do it, but more of the concepts and everything. So really good talk. It was funny because I walked in the room right as it was getting ready to start, and I had to stand the whole time because there was no seats available. All right, so it was, and people stayed the whole time, but to include everyone who was standing. To me, that shows something. People willing to stand for a whole hour. So that's, Sean, I'm going to turn it over to you.
Yeah, I paid a lot of people that day to stay the whole hour. All right, I'm going to see if I can present, and I want to see if I can share my screen to make sure the right one is being shared. Nope, not that one. Okay, so let me know if you cannot see my screen. Hopefully you can.
Yeah, we can see it.
Okay, so thank you, Chad. I really appreciate the invite, and it was a lot of fun last October when Chad and I were both at Huntsville, Alabama. He was speaking at a conference, and I just happened to be there with another friend of mine, and we ran off to the space and rocket center there in Huntsville, Alabama. That was a lot of fun. And so, Chad, I really appreciate the invite to speak. This is a lot of fun, and I have not done one virtually. I've spoken at several places and conferences, but it's my first virtual one. So what really sucks is when I ad-lib a joke and I don't get an audience to see if it actually went well or not, if I should shut up. So I'm going to just assume I'm A-list material. So we'll just go with that. I am the president of the .NET user group in Tulsa and have been since July of 2009, and have really enjoyed running that group for over a decade now, and got to meet some amazing people, and meeting at other events and other conferences, meeting with people like Chad, like Michael Perry and Rob Richardson, and several others that might be on here as well. We meet at the fourth Tuesday of each month. This month, I think we're landing on the same day as one of yours on the 28th. And I am hosting Steve Gordon out of, I think he's near London. And he's going to talk on some high performance .NET code. All right. Our goal today is for me to show that microservices architecture take a lot more consideration than you may expect. Microservices has become way too much buzzword and not enough real clear thought and direction on implementing good microservices architecture. And I keep mentioning architecture, and I probably will for several times. Because microservices it has a lot to do with code, but it is an architectural decision, not just a design pattern type of implementation. So we're going to talk about what are microservices, why you would use them, and when you should not use them. Talk about some challenges that you will have in creating microservices and getting them out to production. And we'll do a high-level overview on talking about decomposition from a monolith out to microservices. Now, if we were physically in a room together, I would have this slide up and I would say, what are microservices? And I'd like some of your audience participation to tell me, what is your definition of microservices? The problem is that there's not one clear, concise answer on microservices. There are many different definitions out there. Martin Fowler, of course, has a great definition on it, but it's not the only one out there. And so my take on that is less about a definition and more about the characteristics that make up a microservice. The key aspect, and this is in my humble but correct opinion, the key aspect on microservices is that they should be treated, developed, and maintained as independent applications the entire time. It is code that is developed for a purpose that needs to be fully considered of an application lifecycle management, where you have the development of requirements, your timelines, your dependencies, etc., and understanding how much the development's going to get done, plus the deployment to for testing, to different types of testing, and then finally out to production. Microservices communicate over a network, unlike just another DLL or NuGet package and such, and it's sitting in memory, and you can just do a call from one piece of code to another, simply calling in memory. These are over a network, period. Even if it's on the same server as the monolith, the caller, it's still going to have to communicate over a network. That adds a complication right there, because you will immediately have latency compared to the call that's in memory. And microservices should have a single responsibility. And what this means is that The code inside a microservice should do one thing and only one thing, that being, if it's going to process invoices, it should only process invoices, or maybe it's in the accounting area. It should not process invoices as well as worry about member registration or marketing, things like that. You get too many things in the same basket. It needs to have a single responsibility, because if it's an independent application, and I'm going to be repeating that multiple times through this, for them to have a single responsibility and be independent applications, then they also have a strict set of what they actually do, a strict set of functionality. Now, this does not mean one method. It does not mean one class. It does not mean one project. It does mean that it's one set of business functionality that are grouped tightly together, being, like I said, accounting, maybe for processing invoices, but does not include other business domains and their business processes. And the reason why is you need to have that separation because of differing feature requests, different deadlines, different set of bugs, and you'll end up with a growing set of dependencies. And microservices should be owned by one team of developers. And coming from Agile and Scrum, when I say development team, that includes the product owners and the Scrum Masters, and as well as the developers and the testers. The team should own a microservice. They can own more than one microservice. A microservice should be fully owned by one single team. As code changes for differing features, bugs, and hitting deadlines, you do not want to have other people and other teams affecting and challenging those deadlines. As well as microservices are individually deployable, meaning that they need to have as loosely coupled relationship to code that calls it, or even another microservice that it may call. And this helps keep a loose grip on how often you can deploy, and lessens the grip on dependencies that you have across the architecture. And the other part is that microservices is not just about code. It is an architectural style. And for anybody that's done SOA, service-oriented architecture, this is simply another phase of service-oriented architecture. We'll talk a little bit about that in a minute. So when we talk about a monolith, the word monolith is not necessarily a bad thing. It's a single code base that includes functionality for more than one thing. Well, it could be a single thing, maybe it's just a monolith and not really considered a microservice. It just depends. But a monolith has more than one set of business functionality, business domains built into that code base. And usually what happens that monoliths, when they become bad, is because they've grown over time, maybe because of multiple developers, maybe because of bad development practices, lack of design patterns, things like that. You end up with what could be what's called the big ball of mud. And that big ball of mud that becomes spaghetti code essentially becomes harder and harder to fix, to change, to add features to. And as it usually happens when you've got 13 bugs, you fix one, and you end up with now 23 bugs. You need to have some clear, concise functionality split apart in there, and we'll talk a little bit more about that in just a minute. From a monolith, microservices are usually where they take the business functionality and they will extract that out, so that the monolith will no longer have that functionality, or simply maybe through execution code, a little fork in the road or feature flags, for example, it's just no longer called. Instead, it makes a call over to the microservice that now has that existing code moved over. And you may have a reason for developing a new microservice that is new code instead of pre-existing. You're more likely to move functionality and add functionality but it's going to be rare that you will do a total migration. It's not impossible. People have done it. But when getting started with microservices, don't look to doing a total migration. It's going to be trying to, the phrase, how do you eat an elephant? One bite at a time. That monolith is that elephant. You're going to want to do it a bite at a time. A microservices architecture is an implementation of distributed computing. And this picture here is meant to depict 5 different microservices calling each other, but they have different number of instances of those microservices running. And the idea is that it's distributed computing so that you have processes that rely on other processes that don't necessarily have to be on the same computer in memory. So why should you do microservices at all? In my, again, humble but correct opinion, the number one reason for doing microservices at all is for time to market. When you need to deliver business functionality quicker, safer, and more stable. And usually what happens with that monolith that has grown to turn into spaghetti code, that big ball of mud, is that every new feature that the business needs to get out there becomes yet another 6-month project with a deadline that's very questionable. For businesses, this can mean a lot, since they may request a new feature that gets them to inside of an industry and be the leader of that functionality in that industry. That's a lot of money. It's a lot of gain for that business. This is probably the same business that's employing you, so you're going to want to help where you can to help deliver business functionality quicker. Like I said, it's safer. It's safer because you're minimizing the amount of code and the responsibilities inside of a microservice compared to the monolith. Now, I say more stable. That's really debatable on that, because, and as we get into a little bit later, you still want to make sure that the code that's in the microservice is still well built using good design practices, development practices, and has the time to do it right and do it well. So 4 key areas for microservices. And the first one is team autonomy. With team autonomy, and being where that a Microsoft is owned by a single team, the team can decide what is the best language for the job. One of the best examples on this is where a monolith may be written in C# and a microservice is written in Python because it's doing data analytics. With data analytics, usually Python is a stronger language than C#. Not that it can't do it, but generally Python is better. It's about the right language for the job. As well as the team can focus on exactly what needs to happen for that microservice. It's not a collection of other team members, from other teams. But the team is responsible for that independent running application and can stay focused on exactly the business processes that's meant to exist for. And if you do use Agile, it works very well when creating microservices, since you have sprints and the ability to change rather quickly. But just as Agile is more about how a structure of development teams than it is about code, this really works well with microservices architecture than the code itself directly. Then we have service autonomy. Back to what I was saying earlier, that a microservice should have one single responsibility as to why it exists. If it does things for accounting, then that's all it should do. It should not also handle part distribution management or keeping up with inventory. It needs to be focused on exactly the minimal amount of stuff that needs to be in there. This is where microservices is technically a really bad name, because there's really nothing micro about it. It's simply that it's not a big ball of mud. It's not a large code base. It's one code base for a smaller set of functionality. And with that service autonomy, you should be able to deploy a microservice that is not dependent not tightly coupled with other things, with other code, and here other services. Now, you may have a service that calls another service, and because there is a feature for the business that relies on a service calling another service. That's loosely coupled, but you should be able to deploy a service, maybe fix a bug, without the 100% requirement that every other service, even if it's another owned by another team, that has to meet your deadlines to get a bug fix out. So if you do have a service calling another service, it might be best if that one team owns both of those microservices. Scalability. Microservices can scale independent of others, meaning in this case, if I've got the green microservice, maybe I need 4 instances of it running versus 3 in another versus 1 in something else. And this also allows a different choice of servers. Be it if the monolith is running on Windows, you can have microservices running on Linux so that you're saving some cost. And they also don't have, maybe they don't need as much CPU and RAM power that the monolith does. This allows you to have that choice. Another aspect is fault isolation. If you have a service that, like A is we're calling on service B that calls on service C, and there's a failure, those failures in that business process will not keep the D and E from communicating. An example of this is with Netflix. They have multiple microservices. You may have a microservice that gets all of the list of available movies for you to pick from. Another microservice will pull up the little preview stream of a movie that you may be on with your app, your Roku or your mobile app, something like that. As you pick through, there'd be a microservice call, pull up that preview, or maybe even the description, maybe even a review. And if the review section microservice was to go down, there's no reason that should stop a user from being able to still pick the movie and watch it. Now, of course, some of those business processes are more crucial than others. If you can't log in, then you can't pay for a product on Amazon. But if you're able to see the product and you just can't get a review, or you can't get how many other people are about other different suggestions, it shouldn't prevent you from still being able to pick that product and check out. So I mentioned Netflix and Amazon. There are 2 among the 3 that I'm mentioning here that have switched to microservices. Netflix, in one, they did a total migration to microservices, and they paid a heavy price. They had to spend a lot of time doing some rework. They'll get a microservice out there. It wasn't really working very well, so they had to go and do a little rewrite. Maybe it didn't go to production. Maybe it was just in load testing, or at least in the test phase. But they had to do a lot of rewriting, a lot of reworking, and because of that becoming a microservice architecture. So they spent a lot of effort implementing a new microservices architecture to get that out. So why should you not use microservices? Now, I know that microservices, they sound great, it's a great buzzword, and there's still a lot of books coming out, a lot of videos about them, and there still should be learned about, but they're hard. And yes, I know I just did that to be funny, but so is good programming. It takes effort to do them and do them well. So you do need to be prepared to have an implementation that you've created and scrap it for something different that is to help for a bigger picture. So when should you not do microservices? If your monolithic code base is simply small, then you probably are better off having multiple instances of that monolith instead of splitting things apart. And if you have too much coupling inside that monolith, you're going to need to do a lot of refactoring. You're going to have to be able to clean your code so that you can get some of that functionality pulled out, as well as modify the areas inside the monolith so that it's now calling that microservice. It has to be aware of what the microservice is and how to reach it. And if your development team is not willing, they're not ready, they're not, they haven't had the time to learn and invest on this different architecture, then you're not ready to go to microservices until everybody's on board. As well, your development team should be supporting what they write. That is, that they are their own support structure. They fix their own code, they fix their own bugs. They're the ones responsible for the features. And something that must be understood is that when you do get into microservices architecture, you're going to spend a lot of time and a lot of money. So we'll talk about some challenges to making microservices. Starting at the top, like I mentioned, it's going to cost a lot of money and time to not just learn how to do them, but to do rework and coming back to the users and say, do we understand, is this really fulfilling the requirements as we thought they were? Developers need to understand, now that there are calls across the network, how are they going to be called? Using messaging patterns and RPC, which is a remote procedure call. Are you going to do synchronous calls versus asynchronous? Are you going to use publish and subscribe messaging patterns? Those will have to be worked out, and there's going to be a lot of times when you may have to do some rework where the RPC style, which I will say that you should shy away from, you may start with that and then go with demands. You may need to work towards an asynchronous messaging pattern. In the past, we usually just copy our compiled files out to servers, bounce the application pool in IIS, and then there we go. You're far better off with microservices, again, being treated as independent applications. And that fully means the application lifecycle management, which includes the continuous integration and continuous deployment pipelines per microservice. You should be able to deploy a new microservice at least multiple times a day if that's what's required, maybe because of a bug fix or simply because of tiny little features getting out. But by having a pipeline to itself, it can be deployable without affecting and requiring and having that tight coupling to other services. And to keep with that, it should also have its own repository. This allows for different languages, different responsibilities, different dependencies, different teams to work independently for the purpose of the microservice. And now we're getting to the part where developers need to understand more about networking. In the past, it was great. You just put a code running out on IIS and you just made sure that the public-facing endpoint could reach that server and you're done. Not anymore. You need to understand how a calling code is going to make a call across the network to a microservice. And as well with that, with the security, it is not required, but highly requested that the caller that calls the microservice is using a form of TLS. And I say form, but something like maybe Istio, for example, that can use TLS, even though it may be on a private network. If you brought in somebody else's NuGet package, a third-party code, unless you have personally gone through and understood every bit of their code, how are you sure they don't have malicious code in there? And if their NuGet package is dependent on another NuGet package, you're going to follow this tree of dependencies that may have security risks. At the company I work for, which I'll tell you in a little bit, we deal with that. We have to know what's in there. We cannot allow malicious code. And if there happens to be any, we cannot allow that malicious code to just be able to call anywhere else in the network. So private or public doesn't mean anything to us. It is we secure every single call. Now, you also need to understand something like the OAuth for accessing the microservice. And this comes back to, just because you may know who that caller is based on an endpoint, you might want to secure it down and at least have some form of a authentication so that that caller must be allowed to call in and access that microservice. This would keep from other microservices from just being able to tap into other places and trying to leverage code. Then you got more of cross references that should not be allowed because it could actually break, harm business processes and any reliant data. And also, we've been in the past where we'd have common code that do not repeat yourself principle, right? Keep it dry. The problem with that is that you're getting a tight coupling between the microservices or the microservice and the monolith that will actually prevent and possibly hold up a deadline. I'll discuss that in just a little bit. And on the networking, developers really need to have not 100% understanding, but understand that there is a thing called an OSI model. Now, there is also a TCP IP model that is far less layers, but I refer to the OSI model since it's been around longer and one I'm more familiar with. But a lot of the communication that happens with microservices is going to be on layer 4 as well as layer 7. Why does this matter? If you're going to put a load balancer in front of your microservices instances, then you're going to use a load balancer, but you may use a different type of load balancer. If you happen to be using an Azure load balancer, that's a layer 4 load balancer. It does it at the TCP level versus a layer 3 with like a Palo Alto device or a layer 2. They're responsible for different layers and for different reasons. Now, if you get into MVC, which is the fantastic acronym that's missing a letter, with model view controllers, how does the calls come in and reach the different controllers? Well, they go through a router. And it's that router that is at the HTTP level, so it's layer 7. It's an application making that decision on which controller is called and how to handle the data serialization and deserialization and the return. So another challenge that you're going to have with microservices is when you have a tight coupling of shared code. So in this case, if team A is working on their microservice and they're going to go from version 1 to version 2, team B, they're working on their version, and they are reliant on the exact same NuGet package. And in this case, that NuGet package is also homegrown. That's not a third-party one out in the interwebs. A problem can happen where when the changes for the service A are made in that NuGet package to help get them and fit their deadline, it can actually prevent another team for their microservice hitting to their deadline, which is going to cause a lot of code changes, a lot of frustration. This is where that dry principle kind of breaks down. You don't always need to never repeat yourself. Sometimes it's okay to repeat the code depending on what it is and for the purpose. So in this case, in this example, the teams decided to minimize what that center NuGet package really has in it, and they pulled functionality that is specific to their services out to separate NuGet packages. This allows them to evolve separately and for the concise purpose of their microservice. And yes, you still have the dependency of the NuGet package in the middle, and for those familiar with the domain-driven design, this is called a shared kernel relationship. So my advice is to separate the code that changes to their own package for the service that needs it. And if there's code that still can be common, if that's what your choice is with the two teams, that's up to you, how much you pull apart and how much you leave common. But an interesting challenge on this: who owns the code for that center common NuGet package? It's not clear cut in the example, so that part is really going to be definitely up to you and how you are working these out. So another challenge that happens with monoliths is as you are pulling functionality out of the monolith into its own microservice, and you realize, well, there's another dependency. Let me bring that over. Yet another dependency. Let me bring that over. And now I don't mean just supportive code, but when you're muddying the waters of what that service was meant to exist for, and now it's doing more service work than it's meant, it's covering more of the business domain than it's meant to, you end up with yet another monolith, in the sense of a distributed monolith. And the problem that happens is where as you keep moving things over, yes, you'll end up with, yes, including the kitchen sink. And it becomes yet another big ball of mud to be responsible for. Another challenge is decentralizing the data. I had a hard time on this one when I was first learned about this. But a microservice that accesses persisted data, notice I said if they do, because some microservices they only maybe chew on the data that came in and spit it right back out. They don't really have a persistence need. For the microservices that do persist data, you need to have a separate database from the monolith. And the reason why is because even at the data layer, just like it was in code, this is a coupling. And this can prevent the evolution of microservice for those business needs. So in this example, you got the monolith, got individual functionality in there, and I've got a single database. And it's got tables, accounts, customers, orders history, parts one, shipping history, and logging. And you notice I said parts one because as you grow and as you add more and more columns to an ever-changing data model, sure, why don't we go to another table and we'll just increment the number because that's what usually makes sense. And naming things is hard. What you're better off doing is separating the data at where the data makes sense to separate. And here's what I mean by this. In this example, we have the monolith that's still responsible for a single database and a microservice for orders that has copies of the data for parts. And the parts microservice has a data store to persist the parts information. And as things happen, you'll have another microservice specifically for shipping, and it has a copy of the order information. So if you look at the parts database, it's going to have a lot of details to what is a part. And this parts database, in this respect, for this example, is a single source of truth. It has all of the properties, all of the details that make up a part. And in this example, I'm using a manufacturing repository of such, where they're keeping information about parts that they have in stock, in inventory. And you notice things like it has the manufacturer's part number of where the part number that they bought it. And when did they buy that from? What manufacturer did they buy it from? And as parts change, and they maybe have one part number that replaces another, so you have a connection through there. The orders data microservice does not need all of that information. It just needs enough information about the parts for it to fulfill the purpose of an order. So the copy of the data is only enough for the purpose of an order, and it does not include all of the other source of truth information. So when we say have a copy of that data, it does not have to be in its entirety. It too can be scaled to just enough information to fit the business needs. And you notice here as well, I've got a table for ordered parts and orders. So just as there's an orders database, it will have just enough information to complete the purpose it exists. Now, the challenge with this is how do you keep duplicate data in sync? If the parts database is the single source of truth and the part name happens to have a typo in it, how is that getting updated to the orders database? This is where a messaging pattern can come in. This is one example of how you would call a microservice. So we have our monolith. I don't know if you can see my arrow, but on the monolith on the left has its individual business functionality with its database. And a message is published that we are fixing the part name of that part. So it publishes a message. And the other microservices pick up that message, and for those who care, will process that message and update their database for that part and fix that typo. Now, another example with this, and where we get into what's called a saga, is Amazon is a great example of this. You can order a material from Amazon, and it says your order has gone through. You now have an order number, you're getting your email, and then it's sometime later that says, wait, there was a problem with the payment. So they contact you back and say, we can't ship this until you pay for it or fix the payment method. What ends up happening is you'll have a message behind the scenes from one microservice to another, says an order was placed for this part. So inventory numbers are changed, and the microservices that care about that message will process that and adjust the part information, maybe the inventory numbers on that part or product. And then the payment processing is also getting updated and said, here's this customer, here's the payment. And then it's the payment processor that says, no, wait a minute, there's a problem. The payment didn't go through. So the saga can help the coordination of notifying the other microservices that says, hey, wait a minute, we need to do an undo. And each microservice is capable and has the responsibility of what does that mean to process forward, but also process in reverse if we need to undo an action. We may undo a payment since it didn't clear, but we may not undo the order creation. Instead, that microservice will say, I'm not going to delete the order that was recently created. Instead, I'll change its status. Maybe it's something like payment pending. And then shipping is notified that don't go pick that part yet. Don't pick it off the shelf yet. The payment hasn't been processed. And then the customer comes back sometime later and now fixes the payment problem. The payment microprocessor receives that message and it goes through, and that the rest of the information is allowed to go through as well. Shipping department will pick that part, pull it out of the warehouse, put it on a truck, and get it sent. So now, get into another heavy topic. Decomposing a monolith to a microservice. Now, I say high level because this could be me talking and like my friends like Michael Perry, for example, and we could cover this and it would take us at least a week to really cover decomposition and doing it well. And as much as I love to hear myself talk, I'm still working on how well and getting better at decomposition. So when we talk about monoliths, remember we have that a large code base, well, it doesn't have to be large, but a code base that has multiple business functionality. And we're extracting that functionality into a microservice, maybe we're creating a new microservice. And I mentioned that usually what happens in that monolith is that those business functionalities, they're not very clear. They don't have clear boundaries. So if you were to try to start slicing out some of this functionality to bring over to a microservice, what code are you able to do without breaking other things that will not get moved? You still want to get in through there and minimize your code changes, so you're minimizing the opportunity for bugs. This is going to require refactoring and a lot of time to do that. But you decided to not listen to me. You're still going to go ahead and go for this anyway. And if you do get the undertone that I'm trying to talk you out of microservices, you are right. There's just a lot to them. Now, I say that you should definitely learn, you should definitely play and try them out, but understand that there's a lot more to them than just a buzzword. So if you're going to start out, start small. Find some small business functionality. Maybe there's a little bit of processing that is done in the monolith, and you think this is a small piece of code. I can pull this to a microservice. I can work on how it's called, to determine if it needs to be using RPC, remote procedure call, or something like messaging. And in the process of doing that, you're going to understand what it takes to build an infrastructure for just a little piece of code to exist in a different computer, or on the same computer but across a network call, and what it takes to have that be an independent application and well supported. So let's go through an example. I'm going to use domain-driven design in this as we talk through this. This is not the only way. And there's still several other patterns, such as the strangler pattern and such, that I don't have time to get into tonight. But DDD is a good one, and it's been around a while. Now, domain-driven design was not created for the purpose of microservices. But there are many aspects of domain-driven design that can really help out the understanding of that monolith and creation of a microservice. So we have an example of our manufacturing company called Wham Bam, and they make fidget widgets. And so essentially that's their domain, is they create products, so fidget widgets. They're a manufacturing company, so in a sense that's their domain. Now the domain model is that there is code in these different areas. There's code specifically for purchasing, code specifically for production, and code specifically for shipping. And you notice that the one in the middle for the production, that is a core piece. That is a core to the company. And what I mean by that is just about any other manufacturing company has a shipping department. But what do they produce and how do they produce them? That's one of the key things that make that business exist and compete with their competitors. There's other supporting elements out there as well. Be third-party code, you've got the accounting, invoicing code, returns management, the inventory handling. So as we dig into one, and we're going to go into the purchasing and production. And as you notice that there is a parts component on both purchasing and production. This is where we're talking about a production of a part. It's going to have its attributes. What are they creating? But purchasing parts, that's different, because in production, those parts are what they are creating out of multiple parts that they're buying from upstream vendors. Having worked at a manufacturing company almost 2 decades ago, purchasing departments required to buy wire, buy different lengths of wire, different sizes of wire, different screws, different lengths, different even different strengths, tensile strengths of different screws. And as they're responsible for buying, those parts that they're buying are for purchasing, and they're not the same parts for production. Because what they produce at that manufacturing company are the different parts that make up the shippable units that they're selling to their customers. So as I'm here trying to tell you what the differences are as you're working with your what are called domain expert, your subject matter experts, you develop what's called a ubiquitous language. And from this, you have and it's meant to be not just the developers, but the development team, as well as the people that you work with in the business, so that when we say parts, we understand, is this a purchased part or a produced part? And having that clear language helps you understand exactly what you're dealing with and why. It helps keep everybody on the same page. As we dig a little further, you can see where we have aggregates. This is part of domain-driven design where they have aggregates and aggregate roots. And here we have an order that's an aggregate root that calls on another class called orderLine, and that makes up one aggregate, whereas product and part is another aggregate. Now they cross a boundary because order code versus the code for products and parts are meant to exist for two different reasons, and so they exist in what's called a bounded context. And in this example, you see how order line, for an order, a line entry in an order, they need to have information about the produced part. The rule that Eric Evans, when he created domain-driven design, is that an aggregate is not allowed to call another aggregate. Instead, it must call an aggregate root. And the reason for this is to help keep the integrity of the data. If the order line just called over to part and said, I need information, then, or change information, which would be worse, then you have a higher chance of bad data being manipulated. Whereas if they went through the aggregate root through product, then there is either functionality there to affect that part, or there's not. And it helps to govern the integrity. All right, so as we're coming through, we're looking at the functionality of an order, and we're looking at that bounded context as a possible set of functionality here is like submitting or shipping, canceling, and revising, things like that. And you have this order microservice that can help handle a lot of that and help provide that functionality. And as we look at other possible microservices and how they surround bounded context and their aggregates and aggregate roots, you can see where it is possible to have a microservice that can contain more than one bounded context. What you're not likely to see is when a bounded context is used across multiple microservices. Remember, this is that tight coupling. And this could actually add to a challenge of a deadline or broken code, depending on who's working on that code in that middle section. Now, I say that, now there is one case when you will see a bounded context going across microservices. And here I'm just telling you it means tight coupling. Don't do that. But there are times when you will. And those are for cross-cutting concerns. A microservice is more likely to log information the same way the monolith does, the same way that other microservices do. Maybe it's the choice of nlog or log4net, something to that effect. And all of the microservices will use those. And they'll use those cross-cutting concerns to help support that. So, we're coming up to an end. We're going to do a quick review. Microservices are hard. They do take a lot of teamwork, a lot of time, a lot of money for that time, and maybe even a lot of rework of that code. Microservices provide team autonomy, allowing for the right language for the job, and allow an independence from one microservice to another so that they can evolve separately. And a microservice, compared to another one, should have just enough service functionality so that it's not mixing business processes where it could hurt deadlines and getting additional features and bug requests out, or bug fixes. And also you can have scalability where you can have multiple instances of microservices on a different number of instances, on different servers. It allows for that choice. And they don't have to be on the same type as the monolith where it came from. You have that fault isolation where a microservice that may not, if a microservice has a bug or is down for any reason, since it is on a different, could be on a different server and across a network, then it may keep or still allow other microservices to continue working and fulfilling their jobs. So us developers, we need to understand messaging patterns, RPC, which is the direct calling a microservice and you know exactly its IP address and port number versus another instance, or maybe you're going to a load balancer, but it's when it's a direct call, whereas messaging is posting a message and allowing a message bus to send a message, and each microservice picks up that message that they subscribe to and react accordingly. Use continuous integration and continuous delivery pipelines separate per microservice. This helps you keep a loose couple on microservices so that they can be deployed as often as possible. As well, need to understand, and we're talking about layer 4 and layer 7, most common for developers with the network. Layer 7 being HTTP and layer 4 being TCP, the IP address. And we need to understand about securing the communication between the microservices. So that way, if we help lessen our chances of malicious code having a negative effect on business processing. As well, I know we touched very, very briefly on domain-driven design. Again, it's a heavy topic. So that bounded context is the set of code that is independent from other, they're split for code in different business reasons. Like, for example, invoice handling is going to be in a different bounded context than that of the new user registration. Or production versus shipping, things like that. They're going to be in different bounded contexts. And although those are clear lines, that does not mean they're set in stone. If re-architecting happens and you need to change what is in a bounded context, then that's entirely possible. And they are not necessarily separate by project, like a Visual Studio project. They don't have to be in separate DLLs. And usually what you'll see is what helps make up a difference in bounded context is that ubiquitous language. That is, if we're referring to a part that is being ordered for the purpose of the company to create other parts, then that's going to be, using that language, you can see how it's in a different bounded context than maybe the parts handling it for the production side, where now they're creating a consumable part that they're going to sell to customers and to ship out. Some recommendations that I have, I highly, highly recommend these 3 books. The one in the middle is Eric Evans, who created Domain-Driven Design. Chris Richardson's book on microservices patterns is fantastic. There's a lot of great goodness in there specifically for the purpose of microservices. And one that I'm also going through, at least halfway through right now, is that Patterns, Principles, and Practices of Domain-Driven Design by Scott Millard and Nick Toon. Highly recommend those books. I can tell you right now, because I just looked it up last night, the Patterns, Principles, and Practices of Domain-Driven Design is about $38 in print, which is really not bad at all. Whereas the Eric Evans ones, I think his book is still around the $65 mark, thereabouts. I don't remember exactly. So with that, a little bit about me being a cloud architect at TokenX. We deal with encrypting and securing credit card information for retailers. So when I mentioned about we have to care about malicious code and that opportunity of such, and what calls are being made across a network, that we secure not just the customer-facing traffic, but as well as the server-to-server traffic and code-to-code that's not going across memory, but across the network, where we pay very close attention to what is allowed to talk to what, and we keep that very narrow. And I have a friend of mine who also does a Twitch channel, so I mentioned him on here as Developer's Garage. And I believe he talks about 3 times a week, so you're welcome to check him out. So with that, I can open this up, and I'm sorry if there was any questions in the chat. I did not have that chat window up. else my train of attention would derail fast and I would be chasing squirrels. So what questions do you have?
So no, there wasn't anything on chat, but anyone have a question?
That's a lot of people asleep already.
Well, I've talked with Sean a lot about this topic in the past, but I can throw one out there. What about the idea of different code bases sharing the same database? Is that a reasonable microservices pattern?
So, and I'm see where I go back to where I was talking a little bit about that, and through this demonstration or example, I mean, so having multiple microservices accessing the same database is not a good pattern because you want to have the control of the data integrity. And a microservice that owns that database is also governing the state of that data. And if a microservice needs to get a hold of that data, it should call that other microservice that owns it so that there is that governance. Did that help answer the question? Or and was I right?
We've talked about it. Yeah. Yes. Yeah, you got it right that time. Thank you.
Okay. Oh, that time. Yes. Thank you. Yes. Michael has been a huge help with me. Probably a year and a half now, going back and forth on microservices and domain-driven design. And so I really appreciate Michael a lot. What else?
I have a question for you, Sean, if it's okay.
Yes.
So I'm currently working on a solution that encompasses, and it's a microservice solution using many different Azure functions to kind of separate out certain pieces, multiple methods, what they're going to do. We have taken the approach where those all have their own separate databases that they're going to work with. But do you feel that it's fine if going from an Azure approach, that handling some of the workflow or the communication or that's going to occur between some of these functions, that you would use something like a logic app to kind of manage that workflow, that what would occur between these different functions and some of the operations that would occur, but you would still maintain that decoupling between these various services?
So how you come up with a microservice, is it C# code that lands in a DLL, or is that an Azure Logic app or an app service? That part is completely up to you.
Okay.
And in fact, in doing certainly with Azure, Azure Service Bus would lend a lot of help with the messaging implementation on that. So you don't have to use code specifically on a VM, virtual machine, just to accomplish this. If you're implementing a microservice by using a logic app and that's your business processor, then by all means. And you may also write that using a logic app. You may also write it where it is .NET Framework or .NET Core running on different machines, just so you can do a comparison that, depending on your business rules, your business needs, do I need to scale this? Do I need the ability to have not just 10 calls per second, but now I need to be able to handle 1,000 calls per second? Can the logic app handle that? I can't answer that. That's more up for you. But the idea is that as you create those solutions, you might develop it in multiple ways just so you can have a comparison, and so that you can do the load testing and see which one works better. Also with Azure, what's the SLA? Is it 3 nines, 4 nines, 4.5 nines? And you'll never have all 5 nines or even 100%. But that way you can kind of govern and understand what can scale, what can handle the abuse that I intend to have with this business process, and then say, okay, now if this was to go out, how fast could we recover? How fast could we reset things? Then you may be better off on a virtual machine instead of a hosted, a different type of hosted solution in Azure. Just it varies, right? And then as well as like I'll do a lot of what I do with Azure is I've got stuff in maybe in the central U.S. Region, but I have to have a backup on-hand solution in case there's a regional outage, and I can switch over to a whole other region within minutes instead of hours or days.
Yes, sir. Thank you, sir. I appreciate
Yeah,
it.
you bet. You bet.
Sean, the question in the chat is, what about considerations for creating a new application from scratch?
So those are the best ones because you can greenfield a lot of things, but keep in mind that although you do get your choice of programming language, and this is a good time to do it in .NET Core instead of .NET Framework because of their roadmap, or maybe it's for data analytics, like I mentioned earlier, then use a better language for that. Maybe it's Python for your business needs. Doing a greenfield project with brand new code is great because you are not confined and you have a better opportunity for implementing design patterns and better development practices to get it right and get it well. Now, I say get it right, that's a judgment call, but as you see how you're adding features and then maybe you're starting to see, well, this is blending in. This is now I'm mixing things I don't need to mix in as far as business functionality. It's no longer a microservice. You're headed towards a monolith. You have an easier time backing that off and even maybe creating a brand new microservice from that. So hopefully that helped answer that question.
Yeah, and actually to add on to that, I mean, some of the things that Microsoft's coming out with .NET 5, I mean, they're actually even more gearing towards microservices. It'll be right in the framework. So another question you got, what do you envision as being a good measure of criteria for splitting up things into microservices, as well as the high cuts off for the amount of microservices that should exist for a solution? Should separate functions of data operations be microservices themselves?
So where do you draw the line is kind of what I'm hearing. Where do you draw the line? It goes back to what business needs are you really trying to fulfill? And if you're starting with a monolith, I highly suggest you're going to start small, start with a small bit of code, because inevitably, as we all do, I mean, I've never written a bug, but I just don't do that. But I've heard that happens in the field. That you're going to need to be able to stop, change directions. So when you start small and then you move things over, and this is where, although I don't mention it here, but look into what's called a strangler pattern. And the idea is that as you're moving code over and that monolith has less code to process because it's actually in a different code base, then you can move more and more things over. And like I mentioned earlier, it's going to give you that opportunity to go and evaluate, is this enough functionality to do exactly what it needs, but no more? Or are we starting to muddy the line between a single responsibility? What's a microservice? Now, a microservice could have 5 million lines of code. If it does, God bless you, and we'll have some therapy for you. But if a microservice does not have to have one class, one method, and that's it. No, not at all. It's about the size of the business functionality that it's exists for. It's not about the size of the code. So hopefully I'm answering that question, but it's going to be a judgment call, and that's where it's going to take time and money to understand that you may actually have to paint yourself into that corner and then realize, okay, this is the corner he was talking about. Now let's back that off just a little bit. And that's one of the biggest challenges about microservices. Remember, since it is an architectural style, is the ability to adapt and change and tolerate those problems when they arise and back off and go a different direction.
And then one more question we've got here. So we have a common library of data types that we need to share among microservices.
Yeah.
How would you recommend sharing those type definitions? We are commonly having to compile and deploy all the microservices to share the common library when one of those types change.
Split them up. This is where the do not repeat yourself needs to break down. When we say keep things dry, do not repeat yourself, it's good. It's a good practice. However, now we're getting into this part where we have to understand that we're talking about different bounded context. And those contexts, which can be a microservice, they don't have to be, they exist and they evolve for completely different reasons than a different bounded context. So the invoice handling in one microservice will evolve and have different needs of that shared code than another microservice or even the monolith. So at some point, you do need to duplicate so that you allow something to evolve separately. And what I mean by that is as this microservice A, evolves for its purposes, and the microservice B is evolving for different purposes, then what was common and the same may actually have different properties and different functionality of those classes over time. This allows that although, yeah, it's duplicate for now, they evolve and they will evolve separately, and then they are no longer really duplicates. They're just similar. But this allows them to evolve separately without tight coupling. So it's a judgment call on what stays common and is that part of that shared kernel mentioned in domain-driven design, and what is duplicate code for now, meaning it will change because they always do. Hopefully that helped.
Yeah, I mean, just to add into that, I mean, I know with my team, that was one of the hardest parts, was well, we just going to make copies of it, right? And you know, especially because, you know, as developers, especially anyone who's been around more than, say, 5 years,
right?
You were taught so hard to make sure we never duplicate that code, you know, to
right.
to be concise and such.
Yeah,
there's definitely something that's harder to think how to do that better.
Absolutely. And if you look at this NuGet package in the middle, the NuGet package foo that I've, because naming is hard. What if that was a piece of code that was company dependent, as in if it was duplicated and evolved separately, it would actually cause problems for the business as a whole? Then chances are every team or every team member is going to say, no, that we can't change that. That has to stay common. Fine, you risk the deadline evolution of the two different microservices that rely on it, but where you can, when it makes sense, I mean, maybe you start out with very simple shared code. Then when it makes sense to duplicate, then you're duplicating that code for that time being because it will evolve, it will change, since the microservices will also evolve and change separately from another.
That's pretty much what Brian commented. He said, you know, may need to fork the shared package.
Yes.
So,
yep.
So any other questions from anybody?
I've got a shared class that I need to consume by both sides. I'm colliding with a bounded context boundary. And really, you know, I wanted all of those shared types in one place because I didn't have a bounded context. If I have a nice bounded context, I don't need those shared classes.
Right. Well, I won't say that it's true 100% of the time, but yes, you're headed in the right direction. The bounded context, and those, like I said, they don't have to be microservices. As you're refactoring your monolith to maybe, hey, we're going to go and look at microservices in 6 months, and now we can go ahead and spend some time refactoring. You may actually get to a point going, well, because of these bounded contexts, we're able to split what needs to be split, keep common what can be common, or what has to be. And who knows, you may even get to a spot where you don't actually need a microservice because you cleaned up your code in the right direction. But the idea of thinking about a bounded context first is a great step. It's not a requirement, but it's a great step.
So I have a
What else?
question.
Yes.
Who owns the customer record?
Who owns the customer record? That's your choice, because maybe it's the monolith for now, or maybe you make a microservice that's specifically meant to be the guardian of the source of truth. In which case, the customer record comes off of the large overly built database and becomes its own database, and so that source of truth gets moved. But data records is just another point, just like code, of dependency. And that's what I had to wrap my head around when I first jumped into this last week. No, I'm kidding. But understanding that just as we have to deal with shared code, we have to understand the shared data. Who owns the data? Who's allowed to change it? And since we have to understand that microservices is a separation of code in different code bases and treated as, I'm going to say this again and again, independent applications, then so is the data. Else, the data is nothing more than a tight coupling that will hold you back. Maybe not day one, maybe not the next version of that microservice, but sooner or later in that evolution, you will find that it's tighter and tighter coupling that you will have to break.
I like that. I've also found that often when I'm looking at who owns the customer record, it depends a lot on what each business unit means by customer record. A customer to person is very different than a customer to the shipping department is very different than the customer to HR. And so really the customer record is the customer ID, and everybody else is a foreign key to that. The shipping department maintains the details about the last order in your preferred shipping address. And HR includes all of the details about all of those paycheck details. And that definitely needs to not go to shipping. And the salespeople have different definitions of customer, because customer is maybe enough data to, I probably don't have a required phone number or required address field because all I have is their business card and it just says Chad. And so by separating those into bounded contexts where they have overlapping or different definitions of customer, then I have one global customer ID microservice where I call it and say, what's the customer name for this ID? Or what's the account number given this ID? Or what's the ID given this account number? And everybody else just has foreign keys into that contains the data specific to their business unit. At that point, nobody owns the customer record other than that small customer microservice whose sole purpose in life is to validate that account numbers are unique and that primary keys don't collide.
Absolutely. Because microservices is a architectural level change, then I keep stressing this, that microservices are independent applications, not just because it's separate code and not because they can evolve separately, but because they can own data and therefore they are protecting the integrity of that data. So I very much like how you stated that, Rob. And Michael Perry, who's on here, has a fantastic talk about the use of natural key. And Michael, I believe what is it called? The Tale of Two Generals? And then,
what Two Generals can teach us about web APIs is the talk,
Yes, exactly. And that's where I first got introduced to the natural key. respect, because I mean, I grew up with like so many other people where you have a SQL Server database and it's one. You have one database, and if you have another one, that's for test. You have another one, that's for development. And as we talk about distributed computing, we have to have an understanding of distributed data. Who owns the data? And so you summed it up very well.
Yeah, but you ask who owns the customer in a conference room, you're going to get a fight.
Right. Well, and then you go, well,
No, I do. No, I do.
Yeah, yeah.
Mm-hmm.
And then Rob says, wait a minute. My friend Sean said something about ubiquitous language. And now we're getting to get everybody on board to go, this is what you mean by customer. This is what you mean by customer. Having that known understanding, and that way we use the proper terms and the proper phrases, then everybody's on board with what customer do you really mean? Because then it becomes very context specific. What else?
So now I have 100 databases. Who makes sure that they backed up correctly last night?
That's your job, Rob. That's your job. We're going to call you.
That's awesome.
If the development team is responsible for the code, and it's the development team that also changes the schema of that data, then are they not also responsible for the fact that it does get backed up? They may not be the person that set the backup schedule. Maybe they're not the people that have access to the database on Azure or something like that in production, but they might be the ones that say, look, we understand the data. We understand what needs to happen. And if it's not maybe this stuff, because of the type of change, because of the type of business, maybe that backup has to happen hourly, not daily. It should be the data. It should be the development team that understands the business requirements and can tell a DBA, this is how often this data should be backed up.
I like that. Usually what I do is lean on automation for that. So, you know, the DBA department says you can build any database you want, but it must conform to these things. You must have automated backups. You must have authentication based on this credential scheme or vault. And at the point, you know, once I've subscribed my micro database to that automation suite, then yeah, I can have 100 or 1,000, and they could be big or small, and they're still tracked correctly.
Yeah, absolutely. And the other part too is we're kind of talking about relational data, but you know, with my screen that I have up, what's to say that it's not, you know, some of this now gets moved over to Cosmos, because maybe the business requirements say that it needs to be more of a non-SQL type than SQL Server. So it allows for that opportunity, it allows for that choice, which also means you can get the right technologies in place, not just what the monolith has.
Yeah, Scott put a good question in the chat there, exactly about that. So yeah, basically, how do you get DBAs on board? Yeah, saying we're going to go to Cosmos is probably not how you get the DBAs on board.
Well, that's true, but yeah.
I was thinking of a few customers I had when I was consulting, and a couple large organizations where they had I don't mean to sound negative when I say controlling DBAs, but DBAs that were responsible for all data implementations, right? And had to went as far as to say, you just tell us what information you need and we'll build the architecture and structure. Well, then when they have such a strong presence in determining what gets stored when and where and how and backed up, et cetera, I was wondering if anybody had that experience. I guess I've been in a lot of small to mid-sized organizations lately where this hasn't been a challenge, but I could see with large organizations that trying to get them on board and embrace this may be a challenge. I was curious if anybody had any insight on that.
I can only share my my humble,
Sorry.
not correct opinion, and that if you're, like, for example, if you're going to do microservice, it takes the whole team. The whole team has to be on board, and how you define team is up to you, and maybe that includes the DBAs.
Sure.
Yeah, I've had the experience that yeah, the DBAs were the people that were right next to the decision makers. So somebody needed to make a decision. They needed data. They went to the DBA. They say, "I need this report. I need you to get it developed. I need it to run fast. Figure this out." And the DBA needed that power to do that.
Yeah.
So so I've actually found that DBAs don't like the way that application developers manage their data. We want everything to be all transactional, and they want it to be star schema and denormalized and or highly normalized, or whichever way is most appropriate for them.
Mm-hmm.
So I think actually leaning into this idea that application databases are for application data, and you're serving the business decision maker data is in a completely different database, and we're going to publish messages over to you, and you can subscribe to those messages and call a store procedure and populate your data.
Exactly.
Mm-hmm.
And it may come down to, well, since you mentioned reporting, well, if I'm going to make this report, do I have to go get my data from this microservice, then this one, and this one, and this one, and this one? Or maybe you work on a data warehouse solution and you have a microservice that's listening to messages and simply populates its data, its database with those data changes, and then that's what gets reported out from. And I'm a firm believer, do not report from a transaction database.
Yep.
If you've got a database that's meant to handle all these records that could be changing states several times a second, don't report from that.
Yep.
You feed another database with the appropriate data and then report from that.
Awesome. Thanks, guys.
Thank you.
Awesome. Well, thank you, Sean. It was a really good conversation, especially, I think the questions afterwards were really good.
Good.